My name is Lukasz Musial. I actually work in investment banking as a Scala developer. But today we're going to talk about blockchain and how it actually works with the Scala world. So my Scala experience is I've been doing the Scala development for the last 6 years or so, exclusively. But recently, that's probably like 2 years ago, I got interested in blockchain too, specifically in Ethereum. And I've been doing some Solidity development as my hobby for a while. And last year was lucky enough to get the prize for a hackathon I took part in. And also took part in a competition in Switzerland, a blockchain competition where the project I was involved in was one of the top 10 finalists. So there's a bit of credentials to actually know what I'm talking about. Let's maybe clarify some things because I think this is something that comes up quite often, especially for people that are not familiar with this space. What does it really mean to develop on blockchain? It means several things, really. So the first thing really is developing the clients. So you have your blockchain network, whether it's Bitcoin, whether it's Ethereum, whether it's something else, but you need to interact with it from a classic application, I would say. So basically, you just need some sort of RPC client that will connect to this network, extract the information you need, and put it into your internal systems. The other thing you can do is develop node of the network, which means you basically become part of what is Bitcoin, or part of what Ethereum is, or whatever other blockchain we're talking about. And this gives you a bit more power in terms of what you can actually do within. You can actually change the protocol slightly. You can create your own fork and experiment with some of the aspects of the blockchain, like, for example, the consensus algorithm. An example of this is JP Morgan actually did a project a couple of years ago called Quorum, which is a fork of Ethereum, which is gaining some attraction from various investment banks, various financial institutions, as one of the solutions that can be used for settling transactions. The third thing you can do is develop smart contracts. Not every blockchain supports smart contracts, but some that do. For the ones that do, it's actually quite a powerful concept. Basically, it means you have at your disposal a distributed virtual machine on which you can run an arbitrary code that you put together in the language of the blockchain actually supports. And if you look at some examples, on Ethereum, well, there is, for example, the smart CryptoKitties application, which allows you to own a virtual cat, which surprisingly is now a cat can be worth like $100,000 for whatever reason. But it's not, obviously, it's a bit of a joke, but it's not the only solution that was those smart contracts were used for. One of the other things is something you heard of, which which is ICO, which is a way of fundraising, and it's been quite an explosion of those projects going on. Effectively writing a smart contract with a client to it, so using a client library and exposing it through, say, browser or through your internal systems. That's called the app distributed application, and there are many examples of those. That's a simplified view of the projects that are currently operating in the blockchain space. And maybe if I have enough cable, I can just point to some things that might be of interest to you if you are obviously a Scala developer, and I take you are because you're here. Definitely the things that worth looking at first and foremost are the projects that are most popular, and as a result they have the biggest developer community, projects like Bitcoin and Ethereum. On top of this, there is the problems that we mentioned, for example, number of transactions that are running on the network that are being addressed by some of the projects, like, for example, the Lightning Network or Raiden for Ethereum, which is effectively a second layer peer-to-peer network on top of the blockchain. If we talk about blockchain specifically, Neo, for example, allows you to write your contracts in C Sharp or Java. And if you look at Tezos, Tezos is written in OCaml, so it also has a very functional approach to the implementation. And in fact, if the question already has been asked, but in fact there are already nodes or implementation of the nodes and the clients for those for the things I mentioned here. They are written in Scala. So there is a Scala client for actually Scala node for a Lightning Network. There is a Bitcoin Scala client which I've seen is actually quite active on GitHub. And there is Ethereum J, Web3J, Web3J Scala. Those are things that you can interact with Ethereum. And the project someone else mentioned from the audience before, which is called Mantis, which is a client for Ethereum Classic. There is a number of other interesting things over here, just to let you know. For example, Polkadot and similar projects look at communication between blockchains, look at actually having a blockchain of blockchains. So to me, it's like a transition from a BBS network to what we now call internet, which is quite a revolutionary thing if it happens, or when it happens. And maybe let's follow up to the next slide. Those are the public projects focused on public blockchains. There is another concept, the private blockchains, where we're talking about a network within some enterprise constraints, so basically a number of enterprise participants creating a blockchain together. For the blockchain purists, it might be atrocity. Realistically, however, it's very attractive to many people and actually can reduce costs of many of financial operations that currently take way too many parties, are too complicated and quite manual in operation. And things worth mentioning, we have digital asset. We have R3 with their blockchain called Corda, which is interestingly written in Kotlin. For those of you not familiar with it, it's basically kind of a Scala-like language to an extent that the syntax is so similar that with a look at one wiki entry, blog entry on the differences between one and the other, you can pretty much pick it up in a day. And Clearmatics as well, mentioned here as one of the possible private blockchains. So what can a Scala developer do? Basically, we all want to have some head start, right? How do we actually dip our toes? What's the kind of easiest thing to do to actually get your hands dirty? So maybe we can just start with looking at Ethereum, which is my personal favorite for the time, which, as you know, is a cryptocurrency. That's a blockchain that actually supports a cryptocurrency aspect to it. It's effectively a distributed virtual machine. So the smart contracts I mentioned before, you can actually run them, and they run on every single node that's part of the network. It's very actively developed. There are forks on it as well, which, for example, including the Quorum, which I mentioned before. While the major nodes of it are written in Go and C++, there are also Java and C# versions of those available. So Ethereum J is a project you might be interested in. The main client library, Web3, is JavaScript. However, and I'm actually going to show examples of this, there is a Web3J and Web3J Scala, which allow you to communicate from JVM with a blockchain. The Mantis mentioned before already. In terms of developing the smart contracts themselves, there is a dedicated language for this on Ethereum. There is it's called Solidity. There are actually several others, which and I think LLL stands for Lisp line language or something like that. But it's a kind of Lispy syntax to it. But one of the most people actually write in is called Solidity. For comparison, let's consider Corda. So that's one of the private distributed ledgers. There's a distinction between those concepts. So blockchain is basically there's a range of technologies that are kind of associated with it. However, when you look at in detail on what various companies do, what various solutions are, you realize that the aspects of blockchain actually, there are many aspects of what people call blockchain, and in fact, what's called blockchain sometimes is not the most important one. The distributed ledger one is however, something that's occurring quite often. So Corda is not a blockchain. It doesn't use this kind of consensus model that Bitcoin, for example, uses, but it's a distributed ledger technology. It's focused on private sector, and it's written in Kotlin. And difference between Ethereum and one other difference between Ethereum and Corda is that you can actually write contracts. So on Corda using Kotlin or Java. Let's have a look at some other differences. So, if one of the things that was specific about Ethereum and public blockchains, the consensus algorithm forces us to do some trade-offs in terms of performance, and those trade-offs come from the fact that the way the consensus algorithm works, and the way this done on Ethereum is, like I said, every node runs the contract. If you have a different consensus, way of achieving consensus, which is a way of determining that event has occurred and we can kind of move on with our life, you don't necessarily have those constraints in place. And in case of Corda, they made those changes to actually optimize it for networks where you have a bit more trust between the nodes involved. So in case of Ethereum, everybody can connect, everybody can run a node and just run your contract, so then can be malicious or faulty agents. In case of private blockchains, those restrictions might be slightly loosened. As a result, for example, Corda is slightly faster than Ethereum is. It's not stellar difference, however there is. And that said, there are also other blockchains that allow you to perform much faster transactions with the trade-off of maybe slightly more centralization of the nodes that do verification of the blocks. So let's have a look at an example how this code can operate with the Ethereum network. So we're gonna have a look at how to generate account, transfer Ether, deploy a contract, and interact with a contract in a matter of just a couple of minutes. So actually, I put together like a little client project, and it's going to be available on GitHub for you to have a look at after this talk. But it's using Web3j Scala, which is also is very thin layer of a Web3j, and it's actually quite simple to use in the trivial case. So there is, if you want to test your applications on Ethereum, you have kind of many ways. You can kind of set up your own networks. You can use shared networks that are available publicly. And the simplest way you can do is you actually have something called Ganache, which is a semi-node for Ethereum, which basically supports most of the operations that you can do with a real network. And as a result, we can pretty much test our contract in the real world. So I'm running a Ganache client, and I have what I'm gonna do now. Actually, it's a wrong project. What I'm gonna do now is first of all, I'm gonna generate a wallet, which means that I'm gonna generate an account which I can use to transfer money around. I already defined two wallets. The one I just got created, you can see this UTC date here. If you look inside, it's basically an address with associated private key, which allows me to perform transactions on this wallet. but like I said, I've predefined 2 wallets already, and I've already set up my network in a way that interacts with those wallets, so I can actually sign the transactions. So if I do the second thing, which is to transfer funds, as you can see here, the ganache was set up with the account. I have 2 wallets here, and what I'm gonna do is just perform a transaction, send the money between. We're gonna see the balances between those 2, before and after. And the transaction has occurred, so we have a balance of the first wallet. We had 7 Ethers on it. We performed the transaction. There is a transaction hash here. We can just have a look in a second on Ganache and see if we can see it there. And we see that after the transaction, the balance is 6 Ether on the first wallet and 2 Ether on the other wallet. So that's simple as that. And on Ganache here, you can see that the transaction has occurred. That's some of the details here, and what other operations were performed on top of that. So that was the second example. The next thing we can do is we can generate a contract. And when I mentioned Solidity, the Solidity code looks pretty much like that. It's a very simple contract here, which just defines a constructor, defines some so-called fallback function, which allows us to fund the contract, to actually send money to the contract. And we define a function that allows us to withdraw the money from the contract for everyone that calls it. So it's not a contract that we actually put on the public network ever, but to demonstrate the case, it's simple enough. So yeah, send a transfer. What happens with what Web3j does? It uses some so-called Solidity compiler to generate the binary version of the contract, and also something called ABI, which is Application Binary Interface, which is basically a representation of the interface that the contract has. So, I've actually already done it. So the code that was generated for it looks like that, which contains the constructor, which contains the function that we can call, also functions that we can use to deploy the contract on the network or load the one that already has been deployed. So if we jump back into interaction example, it's a slightly more complicated example, but first of all, it performs the deployment of the contract, subsequently creates a transaction, which is a bit more involved here. Transactions with the contracts need a bit more data provided, so there is a bit more things that happen. But what it does, it first of all funds the contract, so sends some Ether, sends some money to the contract, demonstrates what balance we have, and then performs the pay me function. So what we said is the function that allows us to withdraw the money from the contract, and eventually shows us what the balance is between the wallet and contract again. So let's run it quickly. And everything happened nicely. So we had, the balance here is a unit called the Wei, which is 1 to the 18th fraction of Ether. And we can see that before we funded the contract, the balance was different. After we funded it, the balance has changed. And we can see that the contract now has a balance of its own. It also is an account, effectively. It also has money on it. Subsequently, we perform interaction with the contract, so we withdraw the money from it, and we can see the balance of the account after the operation has happened. Interestingly, it's slightly different balance than you would expect, because you also have to pay for interaction with the network, which some people actually don't know. That's how Ethereum works. But it's not a topic for this presentation. So let's go back here and quickly wrap it up. If you are going to be an Ethereum developer, you have to realize it's still a young technology in a way. So some of the tooling here is not as great as you would find with if you do your Scala development. You will see very cryptic errors like revert out of gas quite a lot, and sometimes you have to just do really manual things to make things work. Debugging is still kind of early days, and most importantly, the contracts that you're going to write, they're going to end up on a public network, which means you have to be really careful about the verification that what you wrote is actually safe and secure. Be on the lookout on format conversions, data conversions. They can cause a lot of havoc, and also be aware that the different networks have different rules on how things work on them. We're running out of time, so I'm not going to talk much about Corda, but there is a sample here on the GitHub, so you can have a look yourself. And this is probably something that might help you in kickstarting yourself with the development using combination of Scala and blockchain. So quickly. The library I've used is the one over here, and actually uses this one too, so that's worth using too. The node for Ethereum written in Java is Ethereum J. You can find it here. Truffle framework is basically the developer toolkit for writing on Ethereum. Ganache is the simple node that I've used for interactions with the contract. Geth is the main client for main node implementation for Ethereum. So definitely the place where most things happen. Remix allows you to compile on contracts online, and that's quite handy. There is a plugin for IntelliJ. I guess if you're a Scala developer, you're probably using IntelliJ as myself. It's quite nice. It gives you syntax highlighting, so that's quite handy. You might find MetaMask quite useful too if you actually interact with the real networks, as this is a plugin for browser which allows you to control your account and deal with your applications that you write in your browser. To preempt some of the questions that might actually come from this presentation, you might want to have a look at those two links. One is what is gas limit, what gas price on Ethereum, and also what are events that Ethereum can emit. The Corda client you can find here. There is also a Bitcoin Core node implemented in Scala that's worth having a look at, and the Lightning Network node also written in Scala that you might want to look at too. And that's about it. So I'll open the floor for questions.